Let's move on to the second step and calculate the free flow speed. Now, for this step, we have the same procedure as for freeways, but includes factors for median and access point density. So this is the formula for calculating the free flow speed. We have the base free flow speed, which can be taken from the posted speed plus 5 kilometers per hour. And then the adjustment for lane width from table 7.2 is the same as that of the freeway. This is the adjustment for lateral clearance, which includes both right and left lateral clearance. And then this is the adjustment for median type, which we can see from table 7.10. And then the adjustment for access point frequency, which we can see in table 7.11. So here is the table 7.2. It's the same as that of the table we use in calculating the free flow speed for freeways. And then this table is different from that of the freeway. So the total lateral clearance should be equal to the lateral clearance at the right and at the left. So we will use this one and look at the table here. It should be the total lateral clearance in meters. And depending on the number of lanes, since we have 4 or 6 lanes, then you can determine the reduction in free flow speed in kilometers per hour here. So for example, the total lateral clearance is 2.4 and you have 6 lanes. So the adjustment factor is 1.5. The next table shows you the adjustment factor for the median type. So you can have either undivided highway or divided highways. Notice that when we have divided highways, the reduction in free flow speed for the median type is 0. But if it's undivided, we reduce the free flow speed to 2.6 kilometers per hour. This is logical because the more the lanes in the opposite direction are not divided, the driver should be more careful. And this table here shows you the adjustment factor for the access points. So notice that you should know the number of access points per kilometer of the highway. And then you can see the corresponding reduction in free flow speed. Now notice that these are in multiples of 6. So in case that the number of access points is not exactly as the number here, you have to interpolate. Okay, the next step is to analyze the flow rate. This is the same procedure and the same formula we had when we discussed the freeway. Okay, so you have the hourly volume over the peak hour factor times the number of lanes per direction times the heavy vehicle factor times the driver population factor. For the heavy vehicle factor, we also use the same formula as that of the freeways. And for ET and ER, we use the same table 7.4 in determining this one. So this is the table 7.4, which we also used in calculating the LOS of a freeway. The driver population factor is also the same. We have a range from 1 to 0.85. So we use 1 when we have commuter traffic or familiar users. And then, of course, the fourth procedure is to calculate the density of the highway, which is the same procedure. And however, we have a different table for determining the LOS for the multi-lane highway. Once you have determined the density by using this formula, then you can determine the level of service of the multi-lane highway using this table. Okay, you can see here, similar to the one we discussed for freeway, the free flow speed is indicated here. So the corresponding FFS, which are equal to the ones in the table, and the S here will be used. For example, the FFS that you have is 80.5 kilometers per hour. So according to the density that you have calculated, you can determine which level of service the highway condition is. You can also use this chart where the flow rate is on the x-axis and you have the speed on the y-axis. So notice that the speed that are here are lower than those that are in freeway. How to use this chart is similar to how we have used the chart for determining the level of service of freeways. So if you have a density of 6.8 passenger car per kilometer per lane, then you are in LOS, in the region of LOS. And this is the region for the LOSB, the LOSC, D, E, and greater than 28 passenger car per kilometer per lane will be LOSF. Or you can also use the calculated flow rate to graph here. You can have a line vertically upward which will intersect with your speed. So wherever the region of intersection is, then that's the level of service of the multi-lane highway.